Hello all the students. Today we are going to study complete and bounded lattice. So what is a complete lattice? If we consider a poset S comma R, here S is an arbitrary set and R is a partial order defined on set S. So the definition of a complete lattice says that a partially ordered set S comma R is called a complete lattice if every subset of set S has both a greatest lower bound, which is also known as a meet, and a least upper bound, which is also known as a join. So is there some lattice which is not a complete lattice? The answer to this question is yes. There can be lattice which are not complete lattice. That means they do not have a greatest lower bound or a least upper bound, or they do not have both the greatest lower bound and a least upper bound. We have already seen the examples for this in our previous video. Now we will see what is a bounded lattice. Again, if I consider a poset S comma R, where S is an arbitrary set and R is a partial order defined on set S, then the definition of a bounded lattice says that a partially ordered set S comma R is called a bounded lattice if it has the greatest element, which is denoted by 1, and the least element, which is denoted by 0. Now, what is the greatest element? A greatest element which is denoted by 1 is the element such that for all x that belong to x, x is less than equal to 1. That is, the greatest element is one such arbitrary element which is greater than all other elements of the set. What is a least element? A least element is denoted by 0 is a least element such that if for all x that belong to set S, 0 is less than equal to x, or in other words, that particular arbitrary element is less than all other elements of the set S. Now let us consider a hash diagram. Here our task is to find if the given hash diagram is a lattice or not. For this, we have to see if this hash diagram has a greatest and least element or not. So we have to find out whether this hash diagram is a bounded lattice or not, and we will see this by checking if it has a greatest and a least element or not. Clearly A is the least element here because A is less than equals to B, A is less than equals to C, and A is less than equal to D. Or in other words, A is related to B, A is related to C, and A is related to D. So if I check here, I can clearly see A is related to B. A is related to C and A is also related to D through transitivity. Therefore, I can clearly say that A is the least element over here. Again, D is the greatest element here because D is greater than equals to B, D is greater than equals to C, and D is greater than equals to A. Or in other words, B is related to D, C is related to D, A is related to D. That means all the remaining elements of the set are related to D here. I can see A is related to D through transitivity, I can see B is related to D, and I can also see that C is related to D. So clearly my least element in this hash diagram is A and the greatest element in this hash diagram is D. Now since both the least and greatest elements exist, hence I can say that the given hash diagram is a bounded lattice. Now we will see the properties of a bounded lattice. Consider the following hash diagram. This is the hash diagram that we will be considering. Here I know that the least element is A because A is one such element which is related to all other elements of the set. Similarly, the greatest element is F because F is one such element to which all other elements of the set are related. Right? So this lattice is a bounded lattice. Now we know that A here is denoted by 0. Because 0 represents the least element, and F here is denoted by 1 because 1 represents the greatest element. Now Consider some element x. Obviously, x is an arbitrary element over here. That means x could be any element E, C, A, B, D, F. Then the following properties must be satisfied for a bounded lattice. Now, what are these properties? The first property says that x or 1 is equals to 1. Here 1 is f. So, I can say that x or f is equal to f, or in other words, the least upper bound of x and f is equal to f. Now, let us see if it is satisfied or not. Okay, x could be any arbitrary element over here. So, if I take x to be E, then the least upper bound of E and f is f here. If I take x to be D, the least upper bound of D and f is f here. If I take A as x, then the least upper bound of A and f is again f here. So, this property is satisfied for all the x. Now, let's come to the second property. It says that x and 1 is equal to x, or in other words, the greatest lower bound of x and 1 will give you x. I know 1 here is f. So, that means x and f is equal to x. So, let us see. If I choose x to be E, then the greatest lower bound of E and f is E here. Similarly, if I choose x to be C, then the greatest lower bound of C and f here is C. Again, if I choose x to be A, then the greatest lower bound of A and f is A here, and similarly for all other elements. Now, the third property says that x or 0 gives you an x, or in other words, x or A. Since A is representing 0 here, x or A gives you an x. That means the least upper bound of x and A will give you an x. Now, let us see if I choose x to be C. So, the least upper bound of x, that means C and A, is A. The least upper bound of E and A is A. The least upper bound of D and A is A. The least upper bound of B and A is A, and the least upper bound of F and A is also A. So, this property is true for this bounded lattice and for all the bounded lattices. Now, the fourth and the last property says that x and 0 gives you a 0, or in other words, x and A gives you an A. That means the greatest lower bound of x and A will give you an A. Now, let us see if x is C here. So, that means C, the greatest lower bound of C and A would be A. Again, the greatest lower bound of B and A would be A. The greatest lower bound of D and A would be A. The greatest lower bound of E and A would be A, and the greatest lower bound of F and A would also be A. We can clearly see here. So, these are the 4 properties of a bounded lattice. So, this is all for today's lecture in complete and bounded lattice. I hope you understood. Thank you for watching.